In the previous activities, you explored what a continuous integration and continuous delivery pipeline looks like, and you practiced placing security checks at various stages of an imaginary pipeline. You also adapted a secure pipeline to an e-commerce project. Now it is time to go deeper and understand precisely what pipeline checkpoints are, what artifacts are, and why both concepts are absolutely central to a DevSecOps approach. Let's start from the beginning. A pipeline, as you have already seen, is a sequence of automated steps that transform source code written by developers into a deployable and running application. Each step in the pipeline has a specific purpose: compiling the code, running tests, packaging the application, deploying it to a server, and so on. In a DevSecOps context, security is not an afterthought added at the end. It is integrated at every single stage. This is where the concept of a checkpoint becomes essential. What is a pipeline checkpoint? A checkpoint is a defined moment in the pipeline where a specific verification or control is performed before the process is allowed to continue. Think of it like a quality gate. If the check passes, the pipeline moves forward. If the check fails, the pipeline stops, an alert is raised, and the team must fix the problem before the code can progress further. Checkpoints are not optional pauses. They are enforced decision points. Their purpose is to catch problems early, when they are cheapest and easiest to fix. A security flaw discovered in production is far more costly, in terms of time, money, and reputation, than one caught during the first build stage. In a DevSecOps pipeline, checkpoints can be of several types. A static code analysis checkpoint, where automated tools scan the source code before it is compiled or run, looking for known vulnerability patterns such as SQL injection risks, hard-coded passwords, or insecure function calls. This practice is called static application security testing. A concrete example: a developer accidentally writes a function that concatenates user input directly into a database query. A static analysis tool at this checkpoint will flag this code as a potential injection risk before it ever reaches a test environment. A dependency analysis checkpoint, where the pipeline checks all external libraries and packages used by the application to detect known vulnerabilities. This is called software composition analysis. For example, if your application uses an open-source library that has a published critical vulnerability, the software composition analysis tool will raise an alert at this checkpoint and block the pipeline until the team updates or replaces the library. A secrets detection checkpoint, where the pipeline scans the code and configuration files for accidentally committed sensitive information such as API keys, database passwords, or private cryptographic keys. For example, a developer forgets to remove a test API key from a configuration file before committing. The secrets detection checkpoint catches this before the code is pushed to a shared environment. A dynamic analysis checkpoint, which runs after the application is deployed to a test environment. At this stage, automated tools simulate attacks against the running application to identify vulnerabilities that only appear when the software is actually executing. This is called dynamic application security testing. For example, a tool might send malformed inputs to every form and endpoint of a web application to check if it responds in unexpected or dangerous ways. A container image scanning checkpoint, where the pipeline inspects the container image, a packaged, portable version of the application, for known vulnerabilities in the base operating system layers or installed packages. For example, if the base image of your container runs an outdated version of a Linux package with a known security flaw, this checkpoint will catch it. A manual approval checkpoint, used at critical stages such as before deploying to a production environment. A designated person must review the results of all automated checks and explicitly approve the deployment. This adds a human layer of verification at the most sensitive moment. Checkpoints can be configured to behave differently depending on the severity of what they find. For critical issues, the pipeline is completely blocked. For medium severity issues, the pipeline might continue but generate a warning report. For low severity issues, the information is logged for future review without interrupting the flow. What is an artifact? An artifact is any file or set of files produced by a stage of the pipeline that is then used by a subsequent stage. Artifacts are the outputs of pipeline steps, and they carry the accumulated work forward through the entire process. Understanding artifacts is crucial because they are the objects that checkpoints analyze, validate, and pass on. Security in a pipeline is largely about ensuring that each artifact is trustworthy before it moves to the next stage. Here are the most common types of artifacts you will encounter in a DevSecOps pipeline. Source code archives, a zipped or compressed snapshot of the codebase at a specific point in time, representing the exact version of the code being processed. Compiled binaries or build outputs, the result of compiling source code into an executable form. For a Java application, this might be a jar file. For a JavaScript front-end application, this might be a set of minified and bundled files ready to be served by a web server. Container images, a complete, self-contained, portable package that includes the application, its dependencies, and the runtime environment needed to execute it. Container images are stored in registries and can be deployed consistently across different environments. Docker is the most well-known tool for creating container images. Test reports, documents generated by testing tools that describe what was tested, what passed, and what failed. In a DevSecOps context, security test reports from static application security testing, dynamic application security testing, and software composition analysis tools are critical artifacts that must be stored and reviewed. Software bill of materials, a structured list of all the components, libraries, and dependencies included in a software artifact. Think of it as an ingredient list for your application. It allows teams to quickly assess the risk exposure of an application whenever a new vulnerability is published for a known component. Deployment packages, configuration files and scripts that describe how an application should be deployed to a specific environment. Infrastructure as code files fall into this category. Artifacts must be managed carefully from a security standpoint. Here is why. First, artifact integrity must be guaranteed. An artifact that has been tampered with between pipeline stages is a serious security threat. To prevent this, teams use cryptographic techniques such as checksums and digital signatures to verify that an artifact has not been modified. If the checksum of a compiled binary does not match the expected value, the pipeline should reject it immediately. Second, artifacts must be stored in secure, access-controlled repositories. Only authorized pipeline processes and team members should be able to read or write artifacts. If an attacker gains write access to an artifact repository, they could replace a legitimate build output with a malicious version, a type of attack known as a supply chain attack. Third, artifacts must be versioned and traceable. Every artifact should be associated with the exact version of the source code that produced it, the pipeline run that generated it, and the results of all security checks it passed through. This traceability is essential for incident response. If a vulnerability is discovered in production, teams need to be able to quickly trace back to the artifact, the code version, and the point in time when the flaw was introduced. The relationship between checkpoints and artifacts. Checkpoints and artifacts are deeply interconnected. A checkpoint receives an artifact as input, performs a verification on it, and either blocks the pipeline or produces a new artifact, such as a test report, as output that documents what was found. For example, consider a simplified sequence. 1. A developer commits code. The pipeline starts and creates a source code archive artifact. 2. A static application security testing checkpoint scans the source code archive and produces a security scan report artifact. If critical issues are found, the pipeline stops. If not, it continues. 3. The code is compiled. A compiled binary artifact is produced. Pot 4. A software composition analysis checkpoint scans the dependencies listed in the project and produces a dependency vulnerability report artifact. 5. The application is packaged into a container image artifact. 6. A container image scanning checkpoint analyzes the image and produces an image scan report artifact. Part 7. The application is deployed to a test environment. A dynamic application security testing checkpoint runs automated attack simulations and produces a dynamic test report artifact. 8. A manual approval checkpoint presents all accumulated artifacts and reports to a human reviewer. If approved, the deployment proceeds to production. This flow makes it clear that artifacts are not just passive outputs, they are the living, versioned evidence of everything the pipeline has verified. They document the security posture of each release. Why this matters for a DevSecOps specialist. As a DevSecOps specialist, your job is not just to run tools, it is to design pipelines where every checkpoint is intentionally placed, every artifact is properly protected, and every failure triggers the right response. You need to understand which type of check is most appropriate at each stage, what artifacts each check produces, and how to ensure the integrity and traceability of the entire pipeline. A pipeline without proper checkpoints is a delivery mechanism for unverified code. A pipeline without proper artifact management is a system without memory, unable to answer basic questions like, what exactly was deployed, when, and was it verified? By combining rigorous checkpoints with disciplined artifact management, a DevSecOps team creates a delivery chain that is not just fast and automated, but genuinely trustworthy and auditable.